morning, students. Good morning. Today we are studying about the Unit 12, Equilibrium of Forces. Right. The figure shows two groups pulling a rope. Two groups are pulling a drop. This figure shows. So please close your videos. Then, in this figure, you can notice, we can consider in here, this side F1 and this side F2. So, now, you can observe when the forces exerted in one direction becomes, I think already studied in last class, one direction becomes greater than the force exerted in the other directions in pulling in drop, the rope moves in the direction of the larger force. You should know about, in this side, we consider in this side F1, in this side F2. Right. If we consider F1 greater than F2, F1 greater than F2, the rope moves towards the F1 direction. In which side has larger force, that larger force side, the object, the rope will be moved. And second incident, the rope moves towards F2 directions when, in which condition should be maintained in here, F1 lesser than F2. So, in here, I think resultant force is, last class we have studied, subtract from larger force to smaller force. So, F2 minus F1, in which side has larger force, that side the object will be moved, and the directions also mentioned the larger force side. Okay, then when both groups pull with equal forces, in the both groups are full equal forces, F1 and F2, which are equal to F1, which is equal to F2. In this condition, the rope remained rest. The rope remained rest because reason is resultant force is 0. Because the resultant force is 0, so the rope becoming rest. Okay. And then equilibrium of particles, it means, equilibrium means occurs when all the forces are in balance. All the forces are in balance. In here, the two figures are chosen. The total resultant force, so all the forces are balanced, so the total resultant force becomes 0, so the object will become equilibrium. The equilibrium can be categorized into two ways. One is static equilibrium and second one is dynamic equilibrium. Static equilibrium and dynamic equilibrium. You should know about, this is a figure shows, in here, this is static equilibrium figure, and second figure, this shows the dynamic equilibrium figures. Please notice, in here, what are the forces are acting in this, in here. So, drag, thrust, lift, and weight, weight. Right? These are the forces act in this figure. And then equilibrium means definition that forces on an object are balanced. That forces on an object are balanced. So F net, totally F net is equal to 0. So sigma of F is equal to 0. Objects that are in equilibrium can be moving or still. In these two conditions, the objects are in equilibrium. So in the two conditions, object can be maintained in equilibrium during the moving time as well as the still time. Also, we can easy to maintain the equilibrium of an object. Then I already explained the equilibrium can be categorized into two ways. One is static equilibrium and other one is dynamic equilibrium. In here, you can notice the definition of the static equilibrium. An object in static equilibrium is still, not moving object, and all the forces acting on it are balanced. So static equilibrium, what is static equilibrium? Notice students, an object in static equilibrium is still, not moving, and all the forces acting on it are balanced. So motion, still or rest or not moving. In this condition, we can apply the static equilibrium. So the velocity also 0 and the accelerations also 0. So totally F net is equal to 0. So the resultant force also in here 0. Right? All the conditions should be know about. Static equilibrium, it means an object in static equilibrium is still or not moving, and all forces acting on it are balanced. So motion, kinds of motions are included here, such as the first one, still or rest or not moving, all are same meaning. And in these conditions, velocity come also 0 and accelerations also 0. So totally in this condition, F net also 0 and resultant force also 0. Okay. Then now we are going to dynamic equilibrium. So dynamic equilibrium, it means an object in dynamic equilibrium is moving at a constant velocity, and all the forces acting on it are balanced, moving at the constant velocity, and all the forces are acting on it are balanced. So what kind of motions are included in the dynamic equilibrium? The first one, moving at a constant velocity, But in here, velocity is not zero. But acceleration comes to 0. You should know about velocity is not 0, but acceleration comes to 0. But resultant force and F net become 0. Students, you should know about the difference between the dynamic equilibrium and static equilibrium. Static equilibrium, not moving. Then you know about the difference between the static and dynamic. So static equilibrium, it means not moving object, and dynamic, constant, moving at constant. Note it, students, moving at constant. And second one, in here, velocity comes to 0, but in here, velocity not comes to 0. So the main difference between the static equilibrium and dynamic equilibrium, and the similarities between the static equilibrium, this is the difference between the static equilibrium and dynamic equilibrium. But similarities between the static equilibrium and dynamic equilibrium is here also F net is equal to 0. Here also F net is equal to 0. And in here also acceleration also 0. And dynamic equilibrium also acceleration also 0. So now we are studied, what are studied? First, definition of equilibrium. Then equilibrium can be categorized into two ways, static equilibrium and dynamic equilibrium. Then we know about the difference between the definitions of the static and dynamic. Then we know about the difference between the static equilibrium and dynamic equilibrium. Then similarities between the static equilibrium and dynamic equilibrium. Then disequilibrium or unbalanced force. When forces on an object are not balanced, that object in a state of disequilibrium. Disequilibrium. So when an object is in disequilibrium, it must be accelerating. So you should consider these are the main terms. When forces on an object are not balanced, the object is in a state of disequilibrium, and when an object is in the disequilibrium, it must be accelerating. And objects in disequilibrium will always accelerate in the direction of the net force. 3 facts studied. State of disequilibrium, when an object in disequilibrium, it must be accelerate. If object is not equilibrium, F1 and F2, it's not F1 not equal to F2. In this condition, F1 greater than F2, the objects move, accelerate F1 direction. This statement is explained like that way. So objects in disequilibrium will always accelerate in the direction of F net. Direction of F net. Then in here you observe up and down forces. Up force, we are consider upside force positive and downside force negative. And right side force positive and left side force negative. So up and down forces and side to side forces. Up and down and side to side forces. So the object is disequilibrium, the net force is to the right, so is accelerating to the right. I already explained. Up and down force in here F1, F2, F1 is equal to F2, here also 2 Newton, here also 2 Newton. So object up and down forces, resultant force become 0. So the object does not move in the upside or downside. Now let us consider next forces what are acting here. So left, right, in here, right side, 2 plus 2, sorry, 2 Newton, but in here, not force acting here, considered. So the greater force is applied in the left side, right side. So object will be moved in the right side, accelerating in the right side. Okay. So then, so it is impossible to know if they are at rest or moving at constant velocity without more information. Now we are observing here. These conditions, upside and downside, both are equal force, and right and left also equal force. So object become rest. In here also like that way. In here up and down forces is equal, 4 Newton, 4 Newton. So object comes to rest. And left, right side also 9 Newton, 9 Newton. So object comes to rest. So all of these forces are diagram shows the objects in equilibrium. Right. Then you observe actions of two forces. In here, what are the two forces are acting in here? Force exerted by the spring. You should know about labels. Like that question, label questions. One, this is the spring balance shows, then it is a object which is an object suspended on the spring balance. Right, here question like that way, indicate the forces which are acting in here. So what are the forces are acting in here? The first one, weight of an object is act in the downwards, and second one, force exerted by the spring is acting in the upwards. So then label it F1 and W. So F1 is, what is the name of the F1 force? F1 force, please close your videos. Force exerted by the spring. Force exerted by spring. This is the F1 force, right? Name of the F1 force. In here, W force, weight of an object, this is gravitational force. The force which is exerted towards the earth is known as the force which is exerted towards the earth is known as gravitational force. So the gravitational force is equal to W, that is equal to mass into gravitational acceleration. This is mass of an object, this is gravitational acceleration. The value of the gravitational acceleration 10 meter second minus 2 approximately, correct, 9.8 meter second minus 2. Here the two forces acting on an object, one is the weight of the object which is rises due to the gravitational force. The other is the upward force, so downward force, gravitational force. Downward force, gravitational force. The other is the upward force exerted by the spring of the balances in order to keep the object from falling onto the ground. So under the action of these two forces, the object remains at rest. So in here, how many forces are acting here? How many forces are acting here? Two forces. Right? The first one, you observe two forces. Then you observe, according to the figure, to find out the conditions. What are the factors are necessary to maintain equilibrium under the two forces? Now, first we are know about definition. Then we are going to know about how to maintain equilibrium under the two forces of a body under the two forces. Before studied some of the experiments to moving to take a conclusion. Equilibrium of sphere. First, equilibrium of an object we observe, equilibrium of an object, and second we observe equilibrium of a sphere. So in here the two kinds of forces which is acting in here, one is tension and other one is weight. One is tension and other one is weight. Students, first of all, what is tension? What is tension? You should know about the concept of tension. What is tension? In your page, in your book, 204 page, underline it. The force exerted upwards by a string. The force exerted upward by a string. In the string, when an object will be hung on the suspended by a string, an object suspended by a string. In the string, we use the term when force is acting on the string. We use one of the term is used to express tension. How to express tension word? So the force exerts upwards by the string is known as the force exerted upwards by the string is known as the tension. Tension, that is denoted by capital T. Then weight of an object, which is the force is exerted due to the gravitational force. Due to the gravitational force, that is known as weight. So tension, which is equal to weight. So questions like that way, figure shows. This is the two figures shows. This is spring balance, suspend object on the spring balance, and the object will be suspend on spring. Suspend on string. So then you ask, indicate the forces. In here weight, and in here F1 is denoted the force exerted by the spring. In here weight and then tension. You should know about the difference. Why you use the T, tension word? Because the force exerted on the string is known as tension. So it is denoted by capital T. And then you want to know about the how to maintain when these forces are maintain equilibrium. What are the conditions should be maintained? The first condition, F, the force exerted by spring is equal to weight in here. Here also tension is equal to weight. So what is the name of the downward force which is acting on the string? acting on the spire which is suspended by string, downward force is known as weight. What's the name of the upward force? Upward force is known as tension. Then, now consider the equilibrium of under the two forces. Right, this is the activity of this equilibrium of body under the two forces. This is the activity shows. In here, ring and two spring balancers are two spring balancers, F1, F2, balance A, balance B. Then place the ring horizontally on a table, pull it with the two balancers in opposite direction. Then you are know about, now we are applying the conditions. Instant 1, instant 2, instant 3. Balance A, apply the 7 newtons and balance B also 7 newton. You got the observation, the rings stays rest. And then 20 newton, 28, 28, the ring stays rest. 15 newton, 15 newton, the ring stays rest. So, then according to these observations, we take a conclusion. What are the conclusions we take it? The first one, every time two forces are in equilibrium. The first conditions, every time two forces in equilibrium. First one, the two forces are acting in the opposite direction. The two forces must be acting in opposite direction. The two forces. In here, F1 consider and other side F2. The two forces acting in the opposite direction. And second one, you should know about F1, balance A, balance B. Both are equal value. Opposite direction and both are equal value. So the first condition, two forces acting opposite direction. Two forces are acting opposite direction. And third one, second one, both sides, the forces are equal. F1 is equal to F2. So, two forces must have equal magnitude. And third one, both forces must be along in the same line of action. Same line of action. So, two collinear forces. Two collinear forces. Last class studied two collinear forces. Right. So, effective force or resultant of two collinear forces. What is collinear forces? What is collinear forces, students? The forces acting along the same line is known as collinear forces. When an object is said to be in equilibrium, the resultant force of the two forces acting on the object is 0. So, F1, F2, F1 equal to F2, F1 equal to F2. When the object in equilibrium, the two forces are in equal magnitudes and forces to be equilibrium, they must align along the same line and the direction must be opposite to one another. So these are the conditions should be maintained equilibrium of body under two forces. Then another activity, to investigate the factors required to keep an object in equilibrium under two forces acting in the opposite directions along the same line. The first activity using to a ring, examine the equilibrium of forces under the two forces by using a spire or ring, ring. And second one using the wooden block used to do this experiment. In here you can observe the block of wood moves. In here you can apply F1, F2. When F1 greater than F2, it means in here applied 20 Newton. In this side, F1 side applied 20 Newton and F2 side applied 40 Newton. So F2 greater than F1. Okay. So F2 greater than F1, the object will be move which direction? F2 direction. And if object F1 greater than F2, object will be move F1 direction. And when the F1 is equal to F2, object become rest. Okay, yeah? This is the conclusion can be arrived from the activity. So the block of wood moves in one direction whenever there is the non-zero resultant force. In this also non-zero resultant force, in this also non-zero resultant force. This is the resultant force become 0. So when the resultant force becomes 0, the object will be equilibrium. In here also non-zero, the object move in the F1 direction. In here also non-zero, so object move in the F2 direction. That figure shows an object which is a book in equilibrium on a table, and what are the forces acting in here? Weight and the perpendicular reaction. Perpendicular reaction, that is denoted by capital R. Weight is equal to, this equation important, write it and note it. Weight is equal to mg. So perpendicular reaction, that is equal to mass into gravitational acceleration. M for mass and G for gravitational acceleration. Then I already explained what is tension. The force exerted upwards by the object is known as tension. Now we are going to equilibrium of body under the three coplanar forces. Write the forces of, like that question, sometimes asking you for exam paper. Write two examples of the system in equilibrium under the action of three parallel coplanar forces. Three parallel coplanar forces. The first condition, bunch of banana suspend on the horizontal rod, and second one, a child sitting on a swing. The two examples for the action of three parallel forces, coplanar forces. Now observe in here, what are the forces acting in here? This is the perpendicular reaction force R1, here also R2, weight of the object W, and in here four forces are active, but one force is become not considered. That force is rod force. The weight of the rod is not considered, right? So label the forces acting on here. This is R1, this is R2. R1, R2 are perpendicular to the perpendicular forces, and W is weight of the object. And now we are going to observe what are the conditions are maintained equilibrium of body under the three coplanar parallel forces. Three coplanar parallel forces, what are the conditions are must be maintained. The first one, the weight of, in this system of force, the rod is equilibrium of three forces. What are the conditions are maintained? The first one, three forces must be coplanar. The first one, three forces must be coplanar. Right. R1, R2 and weight. Three forces must be coplanar, and then one force must be have the direction opposite to the other two forces. R1 plus R2, that is equal to W. R1, R2, that is equal to W. The result of any two forces must be equal in the magnitude and opposite to the direction of third force. So R1, R2, opposite to the third force, weight, W. So R1 plus R2, that is equal to W. And then this is the activity of 3. Activity 3, this here also, when we apply the forces in the F1, F2, here the 7 Newton taking assumption, and weight is equal to W. So F1 plus F2, that is equal to W. And then 10, 20 Newton. So F1 plus F2 is equal to W. And third one also, F1 plus F2 is equal to F1 plus F2 plus, that is equal to W. So in here F1 and F2 are perpendicular. The first one, F1 and F2 are perpendiculars, and W is weight. So 2 perpendiculars is equal to weight of an object. So the 3 forces must be coplanar, and then 1 force must be conditions. The 3 forces must be coplanar. The first conditions, if you maintain equilibrium under the actions of the parallel forces, the 3 forces must be coplanar, and 1 force must have the direction opposite to the other 2 forces, W, and then in this direction F1, and in this direction F2. Here perpendicular reactions are acted here, and the result of any two forces, F1 plus F2, that is equal to, must be equal in the magnitude and opposite in the direction to the third forces. In here also you can notice what label indicate the forces, what are the forces are acting here. You can notice F1 plus F2, which is equal to W. F1 plus F2, which is equal to W. So equilibrium of body under the 3 forces, what are the conditions? I already explained. And not parallel, if object not parallel, the figure shows the picture remains at rest because the tension of the 2 strings, because this also tension, this also tension, I already explained. The force is exerted on the string is known as, called as tension. These forces are in equilibrium. This is the weight of the object. So in here, sometimes asking questions, label the forces which are acting on here. F1, F2, and then the object weight which is acting on here. So these forces are equilibrium. 3 forces are coplanar, are not parallel to one another. In here, parallel to one another. 3 forces are equilibrium under the parallel forces. F1, F2, both are parallel to weight also. But in here, not parallel. F1 in this direction, F2 in this direction. So not parallel. So 3 forces are coplanar and are not parallel to one another. Coplanar, it means all 3 forces which are meet at one point. So for the equilibrium of system of 3 non-parallel forces, the condition, the first one, 3 forces must be coplanar. That is the first condition. And second one, the lines of actions of 3 forces must be meet at common point. Line of action of the 3 forces must be meet at common point. And third one, result of any 2 forces, any 2 of the forces should be equal to the third force at the magnitude and the opposite to the direction. Magnitude F1 plus F2, which is equal to W. In here, F1 plus F2, 2 forces which is equal to W, weight of an object. Right. Okay, students. So a system, here does not show this figure. You imagine it. Systems which are acting in here. The 4 forces which are acting in here. A system in equilibrium under 4 or 5 forces in here. This is F1, F2, F3, F4. So F1 plus in here F2 plus F3 plus F4, which is equal to W, weight of an object. Right. So what are the conditions are fulfilled for the system of 3 non-parallel forces to be equilibrium? Non-parallel forces the three forces must be coplanar, the first condition. Second condition, the line of actions of that three forces must be meet at common point F1, F2. This is the weight of an object. Both are meet at common point. And third one, the result of any two forces, F1 plus F2, should be equal to the third force in the magnitude. In the magnitude, if take it, F1 is equal to 40 Newton and F2 is equal to 40 Newton. So the magnitude F1 plus F2, 40 plus 40, which is equal to 40 plus 40, which is equal to 80 Newton. W is equal to 80 Newton. Magnitude and opposite direction. In this direction, but the weight is W in this direction. And then you, this is the past paper question. Okay, students, do this question and answer the question through the chat, students. Quickly. Quickly chat your answer through the. Quickly chat your answer.